Re-entry from space is a critical phase in the return of spacecraft to Earth's atmosphere. The process involves several stages and considerations to ensure the safety of the crew and the integrity of the spacecraft. Here's an overview of how re-entry works. Approach and re-entry angle. Before re-entry, the spacecraft adjusts its trajectory to align with its intended landing zone. The angle of re-entry is crucial. Too steep of an angle can subject the spacecraft to excessive heat and G-forces, while too shallow of an angle can cause the spacecraft to bounce off the atmosphere and back into space. Atmospheric entry. As the spacecraft enters Earth's atmosphere, it encounters resistance from the air molecules. This resistance causes the spacecraft to slow down rapidly, converting its kinetic energy into heat. The friction between the spacecraft and the air generates extreme temperatures, reaching several thousand degrees Celsius. Heat shield. To protect the spacecraft and its occupants from the intense heat of re-entry, most spacecraft are equipped with heat shields made of specialized materials like ablative materials or ceramics. These shields are designed to withstand the high temperatures by ablating or burning away as they absorb heat. Deceleration. The spacecraft continues to decelerate as it travels through the atmosphere, experiencing increasing atmospheric pressure and drag. This deceleration reduces the spacecraft's velocity from orbital speeds, thousands of kilometers per hour, to speeds suitable for landing. Parachute deployment. Once the spacecraft has slowed down sufficiently and is at a suitable altitude, parachutes are deployed to further slow its descent and stabilize its descent trajectory. Parachutes provide a controlled descent and reduce the impact force upon landing. Landing. Depending on the design of the spacecraft, the final landing may involve a soft touchdown on land or water. In other cases, they splash down in the ocean, where recovery teams are ready to retrieve them. Throughout the re-entry process, precise calculations, monitoring, and control systems are employed to ensure that the spacecraft follows its intended trajectory and safely returns its crew and cargo to Earth. Any deviations from the planned trajectory can have serious consequences, so re-entry is a meticulously planned and executed phase of space missions.